Hello. Let me start the presentation of lab experiment. I expect that you hear about the large language model lecture uploaded last week. And today we are going to do some prompt engineering and for robot planning for jet rover robot to plan and imagine to succeed the task we give, and then to do such tasks with some manipulation actions. So what we are going to do today is, first of all, we call the LLM API from the internet, Gemini. So get the Gemini from the internet with our API key, and then ask some questions when and receiving the answers. Using that answer, the robot will do the actions following that instructions. So the first part is calling the LLM API, and the second one is planning with LLM. So first of all, for calling Gemini API, we should install this Google Gen AI command following that lines, and that error can occur, but that is fine. And to get an API key, we should log in and use our account information. You should go to Google AI Studio and then make an API key. If you are not going to use any kind of free premium cost, it is okay to use free tier because that has also some free usage amount. So first click dashboard, and following the screenshots here, you should follow the creating the API keys. Create a new project and name your project, click create project, and then you can create your Gemini API key. So following this, you can check your API key in that pop-up dialog, and you can copy it and use when you implement a code. Free tier has some kinds of limitations like requests per minute, input tokens per minute, and requests per day. So you should check that kind of limitations and be aware of that limitation. And if that limitation has occurred, then you can use another accounts of other members or use some other accounts. So in common for Gemini 2.5 Flash, it has 20 requests per day. And if it requests more than that amount, then 4 to 9 error should be occurred. And after you get an API key, in JetRover, you should implement the calling API. So editing ZSHRC using Vim. So press I to enter the edit mode and type the API key to notice the robot to know that API key. And when you save and exit to the Vim editing mode, and then when you echo the API key with following command, you may get some command that you pasted. So doing that, then the robot and the program can know your API key, and then you can call it inside the Python program. To write a Python program, you should download files from Google Drive to local JetRobot. So following this link, you should download those 3 Python files and move that files into your robot inside the home directory inside LLM planning, and then the action groups to software on PC to the action groups. The action groups is the file that you already have in JetRover, and when you pasted the files inside the action groups that we give, then you may execute the action group predefined that we uploaded. And to test it, you can launch this camera node and also servo motor node to run the camera and motor. And when you type this Python test gemini.py, you will create the Gemini with an image and prompt. So if you have this kind of camera input, and then when you run this Python program, you may ask like, what do you see in this image? Then the Gemini will answer that kind of terminal as you ask in the web browser. Seeing that Python Gemini test.py, you can write this submission file so that you should execute two phases of the execution, which means, and at the first phase, you should execute actions to explore and analyze surroundings. Because what you have to do is, after exploring for the robot to other surroundings, whether like what is inside where, and where is the red cube or the blue cube is, you should ask with the Gemini, and then you should execute actions to conduct the test goal using that analysis. Like for example, when we give the goal or target task to like pick up red cube and then place it into the left side, then it may plan and imagine to execute that mission. Like if the red cube is in front of the robot, then the robot should pick up in front of the robot and then place left to the robot. To do that, you should understand the phase of two. So seeing that this pseudocode given in Python, in phase one, after executing actions to explore and analyzing surroundings, you should get some kind of analysis like the robot gave, like there is some image and environment around the desk. And given that phase analysis, you should ask some kind of ask Gemini, and then when there are some action lists are given, then you should execute that action one by one to execute on action group, like pick center or look left, look right or something. And then phase two, given analysis and phase two prompt, you should ask Gemini to how can I execute that kind of mission to succeed that task. Then it should return some actions. Given that actions, you should execute that action one by one to complete the task. So the prompt will be looked like that. There are some environment description, task goal, and then output. So the environment description is quite common, so that there's a mobile robot equipped with a robotic arm and a gripper, 3 color cubes and positioned to left, center, and right of the robot. That should be common environment for noticing to the robot. And the task goal should be some kind of task that we can give to the robot, like pick up and place all the cubes in front of the robot, or like switching the position of the cubes or something. And then output should be make the action plan, available actions or something, and you should do something, you should notice something. That kind of things can be prompt tuned with your own. And then the output can be look like that. Look right, look center, look left. And then the action list should look like this. And the program should execute look right, and then look center, and then look left. For this lab experiment, as it is the execution of just predefined action groups, the robot does not need to actually grab or move the cubes exactly. It is enough to just plan in right way and right order. And then in the experiment, we will only need to verify whether the LLM can reason correctly. So today's objective is to complete that teamx.submission file, fill the code and proper prompt regarding the test goal and execute actions according to the LLM plans. And you should not change the test goal prompt, which the TAs will give some tests to test the robot well. And for doing that experiment, you can change almost the code except for the test goal prompt. And please notice that Gemini has some limitation to call. And you should call Gemini multiple times. Then you should give some previous sharing because that Gemini calling function doesn't have any previous memory. And there's an input token limitation. Yeah, please read the API document to get Gemini usage well, and also the exact limitation of the API. For the submission, it is similar to the last week. You should submit by email for one team, just one email is enough. Submit to KHH and Andrea. And for the evaluation, TAs will run 5 tasks in total, 4 random tasks and 1 submit task goal. And please design your prompts so that it can work generally across different task goals rather than being optimized for a single fixed case. As we are going to change some task goals and then score after seeing whether the robot will execute the actions properly or not, you should get some general prompt or instructions. Deadline is for 7 days for each day, each teams, and no late submission is allowed. Yeah, that is end of lab experiment instruction. And any questions so far?